Just like you cannot watch a couple of online videos without bumping into an ad, you cannot look at two files in a Spring application without bumping into a Spring annotation. Spring Framework is super powerful. It gives you a lot of flexibility in terms of how to configure it. And that ability to configure is thanks to some really powerful annotations. So unlike online ads, Spring annotations are the good stuff, right? Think about what Spring is known for. It's known for dependency injection. It's known for interfacing with a whole lot of other technologies. And Spring annotations are an extremely useful way to auto-configure Spring and wiring up components for dependency injection and configure your interfaces with all those other technologies and so much more. The way Spring annotations typically work is you write your code to solve whatever problem you want to solve, just the way you normally do it. And then you kind of sprinkle in these annotations at the right places in your code, right? And these annotations serve as metadata that tells Spring how to process your classes and methods, right? So just by adding the right annotations in the right place, Spring will know how to process your components, wire everything up automatically behind the scenes, and all this stuff. Kind of, it makes your code, in theory, a lot cleaner, a lot easier to maintain, and a lot easier to read. But there are so many annotations in Spring that it can get overwhelming. That's why in this video, I'm going to cover the top 10 annotations that I think are the most important for any Spring developer to know, right? Whether you're an expert or a complete beginner, these are annotations that you're going to encounter time and time again. So here are the top 10 annotations in the Spring framework that you must know. Let's go. Kicking off the list at number 10 is the @component annotation. Now, this is an annotation that I've seen in some applications that's used all over the place, and in some other applications, they're not used at all. I'm going to tell you why. But this annotation is such a fundamental part of Spring that every Spring developer just needs to know, right? While it might seem simple, the @component annotation is arguably one of the most important and useful annotations, right? First of all, there's a class level annotation. What does it mean? It means you annotate classes with this thing. You annotate classes with @component. Now, why do you use this? So typically, there are many classes in a Spring application, and not all of them need to be managed by the Spring container, dependency injected or whatnot, right? There are always certain classes that you want to designate as a Spring bean and certain classes you want to exclude, right? So when you want something to be a Spring bean, when you add this @component annotation to that class, you're basically telling Spring, hey, this class right here is a bean. It's a component of my application that needs to be managed by Spring, right? So this signals to Spring that it needs to do a little bit of work to instantiate this class, make it available for dependency injection and all that stuff. Because you see, Spring maintains a registry of beans in whatever app it instantiates and manages. So without @component, your class would just be a plain old Java class that Spring ignores. But that @component tag flips a switch and it tells Spring to kind of weave in its dependency injection magic, right? You can ask Spring to say, hey, here's my code base, scan my code for all beans which have @component, and Spring is going to scan your classes and detects the one that has this annotation, right? This bean is now going to be created by Spring, and when it gets created, it gets added to the bean registry, right? This is not the only annotation that does this, by the way. There are other ones which do a similar job, and I'll cover them next. But the @component is kind of like the OG annotation that shows Spring, hey, this class matters. It's a part of my app. I want this to be a Spring bean. It brings Spring awareness to your components. And that's the reason why the @component cracks the top 10 list at number 10. This is like the backbone annotation that enables Spring to do its thing, right? You stick this @component on a class, and suddenly you've got dependency injection, you've got AOP configuration and all that stuff. You just created a Spring bean, right? So that's number 10. Coming in at number 9 is a trio of annotations. There are 3 of them: service, repository, and controller. Yes, ladies and gentlemen, not 1, not 2, but 3 annotations that play kind of a similar but distinct roles. You remember how I told you that the @component annotation is used a lot in some places and not used at all in some other apps? Well, when the @component is not being used, it's likely because the app is using these 3 annotations instead, right? First of all, these 3 are also class level annotations, right? They're annotating a class, but why are they needed? So while the @component annotation marks a class as a Spring Bean, well, the fact is there are different types of Spring Beans, right? Some play a role of stateless business services. Some act as data layer classes. They connect to the database and fetch and update data. Some act as controller classes. They accept web requests and they return responses. They're all Spring Bean, of course, but they have special purposes or roles. You can still mark all of them as that component and they will work. Spring is going to look at those classes and register them as beans. But remember, we are providing metadata to Spring, right? It helps to tell Spring that not only is this certain class a component, it also informs Spring and other developers reading the code that, okay, this is a service bean or a database repository bean or a controller bean. So that's the point of what's called stereotype annotation. They are stereotypes. They stereotype certain beans as belonging to be of a certain type of beans, right? You're saying, okay, all you guys are repositories, all you guys contain the business logic, and all you guys over here are web controllers, right? You're stereotyping them, you're classifying them. So what are these three annotations? First up, the @service annotates that the classes in the service layer contain business logic, right? They mark a certain class as something that belongs to the service layer and it contains business logic. These classes, these should be classes that handle business workflows and calculations and all that stuff. So just like the @component, the @service annotation tells Spring to manage these classes, right? Make them available for auto wiring. But with this added metadata, that this is not just any Spring Bean, this is a business logic bean, all right? Next up is the @repository. This annotation marks data access objects and classes that interact with the database or other persistent stores. The @repository typically, the classes that are marked as @repository typically contain CRUD methods for accessing and persisting data. Again, although it doesn't have to, right? You can still mark them as @component, but @repository gives this extra information. Finally, the @controller annotates web controller classes that receive HTTP requests and return responses, right? Controllers are like entry points inside your application from the outside, right? The controller annotation allows classes to be detected by a framework inside Spring called the Spring MVC framework. And that's the framework which makes these controllers do the job of being that web request handler. So while their roles differ, what's common across all these three annotations is how they clearly mark the purpose of these different classes in your code. @service for services, @repository for repositories, and @controller for web controllers. First, you get what's called intention clarity, right? By using stereotype annotations instead of @component, you clearly state the intent of the class. There's not just any managed component, it's specifically a service that forms a part of the business logic layer or a repository or whatever, right? The second advantage is maintainability, right? For larger applications, which have thousands and thousands of classes, distinguishing between service layers, data access layers, and controllers help with understanding the structure and kind of like the purpose of the code really quickly. You can look at the class and go, okay, this is a repository, right? You can kind of stereotype that in your head. And again, in case you're wondering, it's just a convention, right? You can take these annotations and annotate any Spring Bean with these stereotypes, right? But whoever is reading the code will be very confused if you tag them wrongly. So don't do that. So by leveraging this trio of annotations properly, your Spring app's structure and intent becomes very, very clear. And that design clarity is the reason why these three share the number 9 spot on this top 10 list. Coming in at number 8, we have the ever useful @autowired annotation. This super simple and super popular annotation is how you activate Spring's dependency injection magic, right? By adding @autowired to a constructor or a field or a setter method, you tell Spring to automatically wire up that dependency for you. So for example, here is a myService class, which is marked with the stereotype @service, and here is an @autowired annotation on this repo field, right? So this elegantly injects the my repository bean into my service without any manual work, right? AutoWire works by matching data types by default. As long as there's exactly one bean of that field type, Spring will inject it automatically. And if there are multiple, there are other annotations which allow you to qualify exactly which bean you need. But most of the times, AutoWire is like the go-to, and most of the times it's sufficient, right? This auto-wired annotation is what enables loose coupling between your classes, right? Dependencies get wired behind the scenes and you're not doing this manually. So code kind of stays clean and focused on the business logic rather than on this kind of like assembling everything and finding out what the dependent instances are and all that stuff. So add auto-wired eliminates this glue code. It enables annotation-based dependency injection, and it works well with the add component and the stereotypes that we've talked about. So as a result, this secures number 8 on our top 10 list. Moving on. Coming at number 7 is the add value annotation. So this is a property or setter annotation, and this is very useful for injecting external property values into your beans, right? The easiest and the most straightforward usage of this annotation is to just annotate a fixed value, right? You want to have a property of a bean injected with a fixed value. Here, I'm injecting a string hello world to greeting message, right? It's a simple usage. If you do this to a property or a setter of a Spring component or one of the stereotypes, it tells Spring to set the value of this property to this fixed value. Fairly simple, right? However, the true power of this add value annotation is that you can ask Spring to set not hard-coded values, but values from property files. You can have a property file key value pair and then use the key and ask Spring, hey, find the value from the property file and inject that to this field or setter or whatever that has the add value annotation, right? The syntax is fairly straightforward. You just use the add value annotation and then put this expression, the property name, to a field or a constructor or a method parameter, and it injects the property's value there. For example, this one would find database.url property from the property file and inject that value into whatever the add value annotation is annotating. This is useful for several reasons. First of all, it promotes loose coupling by injecting property values instead of hard coding strings, right? Makes it configurable. It also externalizes this configuration, allowing you to manage all these environment specific values in one place, right? This is even more useful when you're dealing with externalized configuration with microservices. You use add value to kind of fetch that value and you don't care where the value comes from. You configure that somewhere else, right? So this annotation is super useful already, but it actually takes even more power thanks to SPEL, right? The Spring Expression Language. You can think of Spring Expression Language as a way to kind of write syntax and give it more power in terms of what you're fetching, right? You can do things like you can have Spring dynamically inject system property values into your bean properties, right? For example, this annotation fetches username, right? It would inject the logged in username into this property. You can even have it get values from other beans, which is super cool. So the key benefit of the add value annotation is that it kind of lets you decouple your application configuration from your code, right? Keep that separate. You can change the property values without changing the code, without recompiling the code, right? Because it's getting from outside, right? Externalized configuration. But remember, this thing actually works only if the class that contains this add value is a Spring bean itself, right? It has to be annotated with either add component or one of the stereotype annotations, right? Spring is not going to go find all add value and inject it, right? It looks at the Spring beans that it's already managing and putting to the bean registry. And for those beans, if there's add value, it is going to do this stuff. So just keep that in mind. So this is add value at number 7. Coming in at number 6 is the powerful add configuration annotation. And what's this used for? Well, in a Spring app, you can write two kinds of Java code, right? So one is code that does your business logic or whatever logic that serves the user of the application, right? And on the other hand, you have code that's purely meant for configuring and initializing Spring itself. Okay, so this is code that doesn't serve the end user, but it's useful because it is configuring the framework, kind of like at a meta level. So add configuration annotates classes that contain the second type of code, right? Beans and logic, which are explicitly meant for configuring Spring, not your application's use case, not your business logic, right? The methods inside the @configuration class kind of instantiate and assemble beans that Spring will manage, right? So while the @component bean classes are containing your business logic, and of course all the stereotypes, they contain your business logic, the @configuration classes contain your setup and wiring logic, right? The @configuration classes are not doing the work of your app, they're setting up Spring to do that work, right? This separates the app wiring from the app behavior. So for example, here is a myConfig class, which is annotated with @configuration. This marks this myConfig class as a class that contains logic for wiring Spring. And while these classes are meant for configuring Spring, there's nothing stopping you from writing application logic in them too, right? So for example, a feature of @configuration classes is that you get dependency injection in them, just like any other Spring Bean, right? So here I have an order service config, which is marked with @configuration. And inside that, I'm doing dependency injection, right? I have setters which can be dependency injected, right? This allows dependencies like repositories to be injected into the configuration classes. Configuration can also be used with another annotation called @component_scan to auto-detect beans across packages, right? This is how you tell Spring to go scan my code for annotations that are @component or @service or @controller or @repository, right? This @component_scan takes in the package name that it needs to scan, and it goes and scans all of that. If there is one of those annotations, including the stereotype annotations, it's going to pick that up and make that as a Spring Bean, right? And with this, you have initialized any number of classes with one @configuration annotation in your code. Moving on to number 5, we have the answer to the question, ability to create beans in Java code. How? The answer is the @bean annotation. The @bean, firstly, is a method level annotation. You can use it to annotate methods of a class that's been marked with @configuration, right? The @bean annotation tells Spring, execute this method, and whatever this method returns, take that instance and make that a Spring Bean, right? So this is different from annotating classes where you say, hey, Spring instantiated. Here what you're doing is you're saying, hey, Spring, call this method, and whatever I return, make that a bean. By adding the @bean to a method of a configuration class, the method's return object will be registered as a Spring Bean. So for example, here I have a myConfig class, which is annotated with configuration. And now I have a transfer service method, which has the @bean annotation. Now, transfer service will be a Spring Bean registered in the bean registry and available for dependency injection. Now we might be wondering, well, if @component already creates beans, how is @bean any different? For example, just sticking the @service on the transfer service class would have made it a Spring Bean too, like this. So that's true. You would get the default type-based auto-wiring. The key difference is @component beans are used to do the default auto-wiring by type, whereas @bean allows full control over construction through the method signature, right? Here I have a method which is annotated with @bean, but it basically creates an instance and then sets a flag and sets an account number. So these are things that you can do during the creation of a bean that you really cannot with a stereotype annotation. So by mastering this annotation combo of @configuration and @bean, you can pretty much ditch all the other ways of configuring it and do this in a very Java way, right? So this Java-based appeal is what gets @bean at number 5 on our list. Coming in at number 4 spot is the @transactional annotation. This annotation is how you declaratively add transaction management to your beans. Now, before @transactional, managing transactions, what was done using what's called imperative code. So basically, you write code to start a transaction, then you write code to execute during a transaction, and then you write code to end the transaction. And then, of course, you got to write code to catch errors and roll back transactions and all that stuff. So Spring provides what's called a transaction template, which makes it a little bit easier, but trust me, that isn't fun to write at all, okay? The thing though is, most often, the code that you want to write in a transaction is often present in a single method, right? It's like a scope of a method is the scope of a transaction. That is, the transaction boundaries often align with the method boundaries. So a given service method encapsulates the logical operation or the unit of work that should be transactional. So for example, transfer funds service method should either fully commit or roll back this transfer funds operation as an atomic operation, right? So in such cases, the @transactional allows you to express this in a very natural mapping, in a declarative way. So all you do is you stick the @transactional annotation on the method and you're saying, hey, Spring, this whole method call should be a transaction. Just do start transaction before the method starts, do the commit after the method ends, and if the method throws an error, just do a rollback. So you take care of it. You take care of all the stuff. So this annotation is what does that. This annotation lifts the transaction handling up away from your code and into a metadata level that separates the transaction logic from your business logic. Your code stays clean. You're not going to be dealing with the transaction stuff in your code, and you can focus only on the task at hand, not have to deal with manual transaction management. Coming in at number 3 is the powerful request mapping family of annotations. These annotations are like the backbone of Spring MVC and REST. That is, they're useful when you're writing web applications or building REST APIs. These annotations help you to map HTTP requests in the Spring controller handler methods. So the most commonly used annotation is the @request mapping. Right? It's both a class level annotation and the method level annotation, and you use it on controllers. By adding this at a class level, you map all the HTTP requests to that controller class for that URL. And then on each handler method, you can add more fine-grained mapping based on the path. So HTTP methods, headers, parameters, and all that stuff can be configured at a method level. So for example, here we have order controller, which is mapped to /orders by the request mapping annotation. That's the first mapping at a class level. It maps all requests starting with /orders to this controller. And then the method mapping maps the get request to that endpoint to this controller handler method. So while request mapping is the most flexible, Spring also provides more shortcut annotations like get mapping, post mapping, put mapping, and more for some common HTTP methods. The key benefit of these annotations is how they elegantly map the web requests to your controller classes and handler methods. It makes your controllers clean and maps requests based on the HTTP method and the path to the method in your controller class. This web request routing capability earns request mapping family. Basically, it's a bunch of annotations. It marks this family as the number 3 rank in our list. In at the number 2 spot is the REST controller annotation. As it so happens these days, most of us write REST APIs in Spring that return JSON, not the old style web applications with JSPs that return HTML. So you need to use multiple annotations like @controller and @response body, with the response body saying I'm going to have a response body of JSON to make a certain controller into a REST controller and have it return JSON, which is what you need for a REST controller, right? Well, this REST controller annotation combines these two annotations into one convenient single annotation that declares a controller class that handles web requests and returns JSON responses instead of view templates, right? One annotation that does both. And as a result, since this combination of these two is so often used, REST controller is a very often used annotation for API developers as well, right? So while Spring MVC relies on @controller classes returning templated views, REST controllers just return data. So the @REST controller annotation makes your controller return either JSON or XML data by default instead of the view, which was the former default. So for example, here, because of the @REST controller annotation, the myResponse object that's returned by the handler method will be serialized to JSON and return in the response body instead of resolving to a view template. This annotation is what enables building RESTful web services with Spring in a simple declarative style with minimal code. And since it's so concise and so useful, this is so often used, and that's the reason why this climbs to number 2 spot on our list. And finally, the number 1 Spring annotation that every developer must know is the Spring Boot application annotation. This is the annotation that brings the magic of Spring Boot to the table to begin with. This class is the best and the easiest way for you to make an application a Spring Boot application. Just by adding this add Spring Boot application annotation to your application's main class, you basically enable auto configuration, you enable component scanning. This single annotation makes your Spring app ready for production. Now, under the hood, the Spring Boot application annotation is a combination of actually 3 annotations, right? First is the add configuration, which you've already seen, to enable Spring configuration. The second is an annotation called enable auto configuration, which basically automatically configures your beans based on the class path. And then there is a third annotation, which is component scan, which scans for components and it checks if you have components or any of the stereotype beans in your applications, right? So with this one annotation, your entire Spring application is bootstrapped and it's basically ready to launch. The key value of this annotation is how quickly and easily you can basically set up and configure and launch your Spring application, because it does a lot of intelligent defaults. There's a lot of intelligent auto configuration. You just add this one annotation and you provide any other additional config which you don't like as the defaults and you're good to go, right? It takes care of all the basic defaults. So this reason and this pervasive use of this annotation is what secures its rank as the #1 annotation in our must-know Spring annotation list. So that wraps up my list of the top 10 Spring annotation that every developer should know in 2024. Do you agree with my list? Do you disagree? Have I left anything out that you think is important? Well, let me know in the comments. And if you like this, here is another video that you're guaranteed to like. Click here.